We've spent the last 2 lessons looking at polar coordinates of Cartesian coordinates. So taking x comma y and turning it into r comma theta. Just a brief reminder, we did that by these 4 main equations. We said r is the square root of x squared plus y squared. We said theta was arctan of y over x. We said x was r cosine theta, and y was r sine theta. Those are the main equations we used to go back and forth between x comma y points and r comma theta points. Today, we're going to do a very similar process, but we're going to do this with imaginary or complex points. So, quick reminder, complex points are anything written as a plus bi, and they're graphed as the real comma the imaginary part. So one thing we note, we call a the real part of z, and we call b the imaginary part of z. And then we graph it as a comma b. So if we have this point, negative 4 plus 2y, we graph it as negative 4 comma 2. Real part comma imaginary part. And once we've started graphing these, we could use these same exact 4 equations to take it from this point, which right now is real comma imaginary, or as we frequently call it instead, a comma b, and we can make a right triangle out of it and find r and theta, which is the first thing that we're going to do today. Now, before we start finding r and theta for these imaginary or complex points, let's talk about a couple more important vocab words. First off, when your complex number is written as a plus bi, we call that the rectangular form. If it's written as r comma theta, we call that the polar form. Also, in this lesson, we aren't going to use r and theta. They have different vocabulary words when they're imaginary. In this case, we're going to say r is what we call the modulus, and it's denoted by this z with absolute value signs. So if you are asked to find the modulus, or that symbol z with absolute value signs, you're being asked to find r, square root of x squared plus y squared. If you're asked to find theta, the angle, we call that the argument of z. And we usually write it as arg parentheses z. So that's what we call the angle, which we already know we find by doing the arctan of y over x. Now, one last vocab term. We also have what's called the principal argument of z, which is denoted with capital A. And that is if your angle is between negative pi and pi. If the angle is between negative pi and pi, then we call that the principal argument. If your angle is outside these boundaries, then it's just the regular argument. Now, one last thing before I go through here. What I'm going to do now is take these 2 definitions, these 2 equations that we've learned in previous lessons, and we're going to change them because we're not dealing with x comma y anymore. We're dealing with a comma b. So I'm going to change the x and the y to a and b. Change the x and the y to a and b. Because now we're talking about the real part and the imaginary part. So basically, it's the same equations, the same definitions, the same SOHCAHTOA that we've been doing all semester. We're just giving it different names now. Instead of calling it r, we're calling it the modulus. Instead of calling it theta, we're calling it the argument. Instead of calling it x, we're calling it a, or the real part. And instead of calling it y, we're calling it b, or the imaginary part. So understanding all of that, let's let's try our first problem. So what we're going to do is we're going to graph this problem, and then we're going to list several different pieces of it. We want to list the real part, the imaginary part. Remember, the real part is the A, the imaginary part is the B. We want to list the modulus, which remember is the R. And we want to list the argument, which is the theta, and the principal argument, which is the theta that is between negative pi and pi. Yes, those should be brackets. So let's start by graphing this. We have our real part is square root of 3, and our imaginary part is negative 1. So we're going to graph this as square root of 3, comma, negative 1, right there. Now, to find r, we do the square root of a squared plus b squared. Which is the square root of 3 plus 1, which is the square root of 4, or 2. So I know my r, my radius out to this point, is going to be 2. And remember, this time we don't call it radius, we're going to call it the modulus is 2. Now, let's find my argument. We do that by arctan of y over x, or in this case, b over a. And we notice this is a unit circle point. And I know this unit circle point is going to be right here at 11 pi 6. So there's my theta, or my argument. However, notice that for the principal argument, your theta, your angle needs to be between negative pi and positive pi. 11 pi 6 is too big for that. So we're going to come over here and say, or we know 11 pi 6 is the same thing as negative pi 6. And negative pi 6 is between negative pi and positive pi. So that would be your principal argument because it fits between this range. And that's everything. So we took this imaginary or complex number, we separated it into the real and imaginary part so that we could graph it. So let's color code these. Real, comma, imaginary. Then we found the modulus, aka r, and we found the argument, aka theta, and then we changed that to be between negative pi and positive pi to find our principal argument. So now that I've walked you through one on your own, I would like you to pause the video and try B. Label everything, graph it, find all the different pieces, and then come back and check your work. Let's check your work. Our real part is negative 2. Our imaginary part is 4. I graphed that over here at negative 2, 4 to get me this point right there. Then I found r, square root of a squared plus b squared. That gave me square root of 20. I found my argument, arctan of 4 divided by negative 2. This is not a unit circle tangent value, which does mean that this is a calculator problem. So I typed that into my calculator and I got negative 1.107. Now this is where a lot of you may have gone wrong. This is actually not correct because remember, your calculator is programmed to give you quadrant 1 and negative quadrant 4 values for tangent. However, when I graphed this point, this is in quadrant 2, which means this radian value that my calculator gave me is actually right here. It's the negative quadrant 4 one. And we can see that this would be about negative 1.107 radians. That's a problem because that is not the point I want. The point I want is up here. But because it's tangent, we know that these points are pi apart, half a circle. So all I did was add pi to my answer to get 2.03, and that is that angle. So you have to be really, really careful on your argument anytime you use a calculator and you're graphing it in the second and fourth quadrants. Because your calculator will give you over here totally fine. It will not give you over here. So anytime you type arctan into your calculator, you need to make sure you graph that point. And if it's in second or fourth quadrant, you need to add pi to whatever the calculator gives you. And then finally, for my principal argument, that is between negative pi and positive pi, negative 3.14 and positive 3.14, this angle is in that measurement, in that range. So in this case, my argument is my principal argument. So there was a good example of a calculator one and being very careful with our calculator. The last two problems we're going to do are not calculator problems. They are unit circle problems. So what I'm going to do is have you do both of these problems. First off, we're going to change this to be 0 plus 3i. So then it's a little easier to see our real and imaginary parts. And for D, we're going to change this to be negative 117 plus 0i. So then you can see your real and imaginary parts. And what I want you to do is to graph both of these problems and then find all the things you need for both of them and then come back to check your work on both problems. Let's check your work. So the real part of this one is 0. The imaginary part is 3. So I graph that as A comma B. 0 comma 3 lands me right there. There's my point. R, used my square root of A squared plus B squared to get that my R is 3 up to that point. And hopefully you notice that for the argument, you don't even have to use arctan for this one. Because it lies on your axis, you know that that theta up to that point is going to be pi halves. And pi halves is between negative pi and positive pi, so that's our principal argument as well. And for the last one, real part is negative 117, imaginary part is 0. Plug that into our square root of A squared plus B squared equation to get the modulus, get 117. If I plot this as A comma B, I get out here at negative 117 comma 0. So the radius or the modulus out to that point is 117, which reminds me I really should be changing that. There we go. And you don't have to use arctan. You don't have to use your equation for this one because it's on the x-axis. We know our argument is going to be pi. Now, you could also write this as negative pi, but for the principal argument, notice that negative pi has a parentheses. We don't include it. So for the principal argument, this would also be pi. So that is it for taking a complex number, a plus bi, written in rectangular form, and practicing finding the modulus and the argument from that complex rectangular form number. In the next video, we're going to talk about how to get the polar form, r comma theta, out of these things.